many useful simulations are available under, I guess, physics education technology. Not entirely sure what it stands for, because all I really do is Google PHET physics each time I need to find this. And this has a tremendous number of useful simulations available to us. For example, if I were to go under light and radiation, there are many, many different simulations. Not all of them tie in with what we're doing in this class, but some of them do. Let's take one, geometric optics. And I'm going to use this as just to give you a demonstration of here's something that is happening. Now, you can download this, you can embed this, or you can simply play this as it is. If you have a problem with this, sometimes the problem you have is that you do not have the most recent version of Java or whichever the heck this is that we're dealing with. Now, that tends to update about once every day and a half, so I realize it's a pain sometimes, but if you do have that problem, then typically by just checking to make sure I believe it's like the JavaScript or Adobe Flash or whichever, you'll generally get a criticism saying, hey, you need to update this. Updating it is fairly straightforward, and you can get into this. Now, let me put many rays up. I'm going to use this. Okay, I'm trying. Now this is, there we are. I'm going to move this to illustrate a couple of points, because when we go from chapter 23 to chapter 24, chapter 23 involves dealing with simple lenses, or thin lenses, so that we have just like one equation, or a couple of related equations that describe how those move. When we're dealing with cameras, the first object in chapter 24, it can get a little bit more complicated. So what I've got is, but by using this, there are a couple of things I want to illustrate. For example, if I have here's an object, and I'm looking at the light from an object, then all of the different rays that come from that object in the ray model of light, which are basically infinite rays, some portion of those rays are going to go through a lens nearby, if one is available, and all of the rays that go through the lens are going to come to a focus at a particular point. Now, the two things I'd like to draw your attention to, let me widen this up for this case, that first of all, to find a particular set of rays going through the lens could be problematic. I mean, the geometry is straightforward, but it could be tiresome. If I just look at the three principal rays we discussed, even if those rays don't go through the lens themselves, who cares? They're largely imaginary. We know that wherever two of the rays or three of the rays match up, all of the rays match up, so I don't care if they're not going through the lens. They still help us find this point where that light comes to a point. Now, one of the aspects we're going to see with a real physical camera is that often you will have a quantity listed called the aperture. That strictly relates to how wide is the opening light is allowed to come in through. In this case, that's the diameter of this lens. Now if I change the diameter of that lens, notice that the object isn't moving, the focal point isn't changing. All that's happening is that as more light comes through the lens, the object is brighter. As less light goes through the lens, the object is dimmer. I just wanted to take a moment to put that in video to hopefully avoid a couple of problems working with more involved systems.